Line postulate. Line is an undefined term. If we say that line determines a direction, then we have to define direction. What is direction? So we have to accept certain facts as true in themselves, because they stand true forever, though they cannot be proved to be true. But they also cannot be proved to be untrue, that is false. In all cases, some facts remain true forever. They, the mathematicians, term as postulates. A postulate is a fact that cannot be proved, but it remains true for always. Two different points always remain a unique straight line. If there are two different points, there always passes a unique straight line we learned last time. Now, plane postulate. Suppose there is one point outside the line, then a line and a point outside the line always determines a unique plane. Plane, that is surface. What is surface? Suppose we try to prove what is plane, we have to use the term surface. Then we will have to prove what is surface. Thus, lines are determined by 2 points, but a plane is determined by a line and a point outside it. Now, as line extends infinitely in one direction and the other direction, there are points on lines. Then, if there is another point outside the line, then this line and a point will determine a plane. As the line extends in forward direction and backward direction infinitely, so the plane also extends in all directions infinitely, in all directions up to infinity. It can be said that plane is a surface, it has no thickness, but it has length and breadth. There are 2 dimensions. Line has got only one dimension, that is length. We can measure the pieces of length. Similarly, we can measure the length and the breadth, that is pieces of surface. The surface has got one direction. Point has no dimension. Line has 2 dimensions. Line has 1 dimension. Surface has 2 dimensions. Length, breadth and thickness are the 3 dimensions. A point contains no dimension. It is a position. A line contains 1 dimension. It is a length. A surface contains 2 dimensions, length and breadth. And a space, that is volume, contains 3 dimensions, length, breadth and thickness. All substances, objects exist in space. Now, any line always has at least 2 distinct points, because there are a finite number of points in a line. But these 2 distinct points and the third point outside the line will make 3 points which are non-collinear. 2 points always make a line. Suppose there is a point A and B on a line L, and a P point outside the line. of a stool which remains always in balance if it has 3 legs, track or stool. It doesn't topple because 3 planes are always, 3 points, 3 legs are always in a plane. So the stool remains always in a plane. So it doesn't topple. But a stool of 4 legs, if one leg is not in the plane determined by 3 other legs, then that 4th leg will remain up or down to the plane determined by the 3 legs. Therefore, the stool may topple. It cannot stand in balance. Thus, 3 paired points are always, 3 non-collinear points are always coplanar. Suppose we take 3 collinear points, then from they make only one line, and one line cannot make any plane because a number of plane cases can pass through one line, as a number of lines can pass through one point. Suppose we have a point here, and a number of lines can pass through this point. Then, suppose we have a line. A number of planes can pass through this line. As you have pages of the book, a book has many pages. All these pages pass through one line. So one plane cannot be determined by only a line. Thus, 3 different points are always coplanar. Mark that the point should be different. We also can conclude that 2 distinct lines are always coplanar. 2 intersecting lines, distinct lines but intersect. Suppose we have a line L and an intersecting line M. They intersect in point P. Then any point other than point of intersection will be outside line L, then the determinate plane. If 2 points of a line are in a plane, the whole line will be in a plane. So 2 intersecting lines are always coplanar. Similarly, 2 parallel lines L and M are always coplanar. A plane can always pass through parallel lines. So, lines in a plane can be of 2 types. Either 2 lines, a pair of lines, either the lines intersect or the lines are parallel. If the lines are intersecting or the lines are parallel, they are always coplanar. Now suppose there are 2 lines which which do not intersect, which are not coplanar also, then definitely they are not parallel. If two lines are not intersecting, also not parallel, they will not be coplanar. Coplanar lines always intersect or are parallel. They are called skew lines, which, even though extended up to infinity, do not intersect. Parallel lines also do not intersect. But parallel lines can be accommodated in a plane, whereas the lines which do not intersect and are not parallel, we cannot find any plane containing these two lines. They are called skew lines. If a line goes up like this and forward and backward like this, they, on extending forward or backward, upward or downward, they will not intersect. But we cannot find any single plane containing both these lines. So these lines are non-coplanar. Now, we cannot define a point. We have to take it as a postulate. We cannot define a line. We have to take it as a postulate. We cannot define a plane. We have to take it as a postulate. But certainly we can define a line segment. Definition of line segment. The set of points A, suppose on a line there are 2 points A and B, then there will be other points between A and B. Now, it is a density property of points that between A and B, if there are 2 different points, we can always find infinite number of points between them. All these points between A and B on a line AB make up what is called segment, line segment AB. Now, suppose if we take a point on a line, the point divides line into 2 pieces. Similarly, a line in a plane divides the plane into half planes. A point on a line divides the line into 2 opposite rays with common endpoint. Suppose we have a line L here, and there is a point A on it. The point A will divide the line into 2 parts. One part will be in one direction, and the other part will be in the opposite direction. These 2 parts comprise 2 rays. 2 opposite rays taken together make the line L. So this ray, this is called endpoint of the ray, and suppose there is another point B on it. So this is called ray AB. We put an arrow mark here at the end. Now A is the endpoint of ray AB. Similarly, there is point C on the opposite ray. It has also the same endpoint. So we can write ray AC. A is the endpoint and C the other point on the ray AC. Thus, ray has an endpoint. Ray on one side goes infinitely in a certain direction. It is always having fixed endpoint, and other points of the line giving the ray. Now, that definition here, between them. So these are all points C, making A dash C dash B 2. That will make up line segment AB. So line segment AB is a set of point A, point B, and all other points between A and B. So here we have to take into account the property of betweenness. 2 points A and B between a line. Any point which is on the line but between A and B, we say that it is the point A dash C dash B, such that distance AC plus distance CB becomes equal to distance AB. It is the betweenness property of point C. Thus, the definition of line segment AB, AB is a line segment of all points, union of all points A, B, and all such points that A dash C dash B is given. Definition of our ray AB. Now, here also we make use of the line segment AB and the property of betweenness. Suppose we have a line segment AB like this, and instead of taking point C between A and B, we take point C on the other side of B compared to A, on the other side of B with respect to A. Then this AB is a line. Point A and B are different points. Segment AB is the line segment AB. Here A, B and C is a point on the other side on the line AB. Then it happens that B comes between C and A. So point C can be here, here, here. It can go on up to infinity and got no definite position. Goes up to infinity in a straight line. All these points may be true to be A dash B dash C. So, definition of ray AB. Ray AB is the union set of all points of segment AB and all such points C such that A dash B dash C is true. It is called the ray AB. In the ray AB, we mark an arrow with end point above the letter which is the end point, and the other above the other letter we may point here, arrow here, and point here. So AB is a ray, A is the end point, B is any other point on the ray. It extends up to infinity on one side. A ray is always determining one direction. Here, opposite rays have fixed endpoint, permanent. But suppose the rays are non-opposite, what will happen? Suppose there is a point A and point A, and another point B on the ray AB, and another point C on ray AC. Then this type of construction will make angle CAB. So, dear students, we will study this properties of angles and lines in the next. Till then, prepare the definitions, postulates properly well.